So many ways to attack this one. We could start by getting rid of the radicals in the bottom, multiply top and bottom by root 12 and by root 6. That would do it. But you'd end up with bigger numbers and a bit of canceling there. You could look at, well, the numbers in roots are root 3 and root 12, and 12 divided by 3 is 4, and just be left with root 4 on the bottom and root 3 on the bottom for the second term, and that's perfectly good too. Let's find something in between, and we'll approach it that way. So for root 3, let's break down that 12 into root 4 and root 3. And we broke it into that for two reasons. One is if I match the root 3's on top and bottom, I can cancel them out. Another bonus reason here is that I know the root 4, so that'll work out nicely. The second one is I can say 3 root 2. And now this one, there's no way to break down root 6 into something that we can take out of the radical. There's no perfect square that goes into 6. So, but we could end up doing root 3, root 2 simply for the idea that those cancel. And so that kind of brings us back to that second method I talked about at the beginning, is that we're just recognizing that the numbers in the radical are divisible, so we can break them down that way. So here we are. We could write this out as 4 over 2 minus 3 over root 3. Okay, so going to the next step, we could get rid of the radical on the bottom before we make common denominators and try and clean this up. I don't know if we bring common denominators into it, it's going to work out very nice anyway, but let's go for it from that point of view. So if we multiply the top and bottom by root 3, let's see where that takes us. Our first term, 4 divided by 2, is just simply 2, so done with that. Now, the 3 root 3 on the top, and then root 3 times root 3 is just 3, and those cancel out. And so, yeah, we're going to end up in a case where we don't even have to worry about common denominators because fractions are gone now. And so, yeah, we're left with that. There's no more we can do. That would be a good final answer.